Welcome back to the Iclix Academy. In part 1 of this series, we covered the fundamentals of BGP. We discussed what BGP is, the difference between eBGP and iBGP, autonomous systems, and how BGP uses TCP port 179 to establish neighbor relationships. In today's video, we're moving from theory to practical configuration. All point-to-point IP addressing and Layer 3 connectivity have already been configured, allowing us to focus entirely on configuring BGP using Mikrotik Router OS v7. In this lab, we are the Internet Service Provider operating in AS65001. Two different customers, each with their own autonomous system, want to establish an eBGP peering session with our ISP. By the end of this video, both BGP sessions will be established and we will verify that routes are being exchanged successfully. Before configuring any routing protocol, always verify that Layer 3 connectivity is working correctly. BGP establishes its neighbor relationship over TCP port 179, but before that can happen, the routers must already be able to reach each other. Our Layer 3 connectivity is working, so we can begin configuring BGP. Step 2. Create the BGP address list. The address list tells BGP which networks we want to advertise. Instead of advertising every route on the router, we explicitly specify the prefixes that should be announced to our neighbors. Step 3. Create the BGP template. The BGP template defines the identity of this router. Instead of configuring the same settings for every neighbor, Mikrotik Router OS v7 allows us to place the common settings into a template. This makes the configuration much cleaner and easier to manage. AS number. The autonomous system number identifies our network on the Internet. Since we are the ISP, our autonomous system is 65001. Step 4. Configure the BGP neighbors. Now we're going to tell Mikrotik who our BGP neighbors are. Each neighbor requires two important pieces of information: the neighbor's IP address and the neighbor's autonomous system number. Remote address. This is the IP address of our neighbor. Remote AS. This must match the neighbor's autonomous system number. Role. Because the customer belongs to a different autonomous system, the role is configured as eBGP. You'll notice that I've enabled both Connect and Listen. This is Mikrotik's recommended approach in RouterOS v7, as it allows the router to both initiate and accept BGP connections, making the peering process more robust. Step 5. Verify the BGP session. Go to Routing BGP Session. If everything has been configured correctly, we should now see the session state change to Established. The established state confirms that both routers have successfully completed the BGP neighbor relationship and are now exchanging routing information. Now that we've successfully configured the BGP connection between the ISP and customer A, let's repeat the same process to establish the BGP session between the ISP and customer B. Earlier, we configured the BGP template and selected BGP networks as our output network. This tells BGP to use the address list we have just created. In other words, BGP will only advertise the prefixes contained in this address list. I'm enabling Network Black Hole because BGP can only advertise networks that exist in the routing table. By enabling this option, Mikrotik automatically creates a black hole route for the prefixes in my address list, allowing BGP to advertise them. This is perfect for a lab environment. Step 6. Verify the learned routes. The ISP has successfully learned customer A and customer B's advertised prefixes. These successful ping tests confirm that traffic is now using the BGP learned routes between the ISP and both customers. For this beginner lab, this behavior is perfectly acceptable because it demonstrates how BGP exchanges routing information. In a production ISP network, we would normally apply routing filters and routing policies to control exactly which routes each customer is allowed to advertise and receive. We'll cover routing filters in a dedicated lesson later in this series.